particular questions you have in mind we could get out of the way first before I jump into this? Anything at all? No? Okay, so just jump into this? Okay, guys. The exam more than likely will open up with a piecewise function to graph. That's been quite a while since you guys have seen one of them. So on the handout, I thought I would try this one. Mr. Park, you think it'll be okay here?
Yeah, it's really okay.
And guys, the pieces in this case were given like this. Three pieces here. Looks like this. And we're supposed to graph that. Now keep in mind, the one you see right now for the example, and I hope I have it copied down correctly. You could. That's definitely going to be probably the first question you see on the exam will be a piecewise. But since the course is finished, this among those pieces could have a log in it. Have a piece of a log graph. This one does not. Okay? Or it could be a piece of a trig function. There'll be signs stuck in there. Okay, guys? So this one I don't think is going to be too bad. Let's see what happens here. The way we approach this in class, did we use a little table? Did I ask you guys to maybe try a little table for each piece and plot a few points? Is that what we did? I think. So let me do this one in black. I think we approached it like this. And this one says you're allowed to replace for x in that table anything less than or equal to 0. So we'll start with 0. And let's try maybe a -1. You can try more if you wish. I think 2 points will be enough there for that one, so I'll come back to it here shortly, guys. My second piece, I'll do it in red. On the XY table, says you're allowed to try anything between 0 and 3, not including 0. But since they gave me 0, place it in here to play it safe. Go down to 3, and anything in between, I'm going to try 1. And I'll come back to that one. Okay, caught between 0 and 3. The last one says, I'll try blue here. There you're allowed to try anything greater than 3. Guys, we'll start out with 3 itself and try 4. And let's hope that may be enough. If not, I'll come back and add more points. Okay, now let's go back and fill in the tables. On the black one there, if I go back to my function right here, replace x by 0, it's not exciting at all, it is 0. If I go back and replace x by -1 with that negative sign prefix, we'll turn to a +1. And I'll sketch that here shortly. The one in red, put 0 into my second piece, 9 subtract 0 squared. Of course, it's going to give me a 9. Put a 1 in there, you're going to end up with 8. Just doing a little math there. Work out for me. 3 is nice because it's going to give you a 0. The blue one, let's put a 3 in the last one, and 3 subtract 3 is going to give me a 0 to work with. And put a 4 in there, 4 subtract 3 is going to give me a 1. You guys agree with those? Okay, just quickly create them. Now, let's see what this put together looks like as a piecewise graph. We'll do a quick sketch here. And you guys, the one in black says start out with 0, 0, and be very careful. I do see the equals mark there, which says I can include 0, 0 on that first piece. I'm darkening that in. Then out -1, up 1. If I plot that, it's going to be somewhere in here. That should be enough to sketch this. As I sketch, should be a piece of a straight line. That one's done. The one in red, gotta be careful, says 0 up 9. And by the way, since 0 is not to be included, I'll go ahead and plot 0, 9, but it's not to be included on the graph. So guys, it's way up here. If you don't mind, I'm gonna stretch this thing up and just quickly show up here at 9. Red is open. When I get to, let's say I could plot 1, 8, since I have it there, and I'll just do it quickly. 1, 8, let's say it's right in here somewhere. That's on the graph, and that's the red one, so I should be using red here. Out 1, up 8, and then of course 3, 0, and that 3, 0 can be included. So the red one, if we have everything correct here, guys, it's going to be a piece of a parabola opening down. That's true, guys? Make sense? Vertically shifted up 9. And the last one, the blue one, says now plot 3, 0. Now I've got to be careful here. 3, 0, I cannot really use 3 here. It says x is greater than 3, not greater or equal to. So 3, 0 now should be open, but what happens? Did I close it previously? So I got to leave it closed. Just closed, I can't reopen it. Then out 4, up 1, we'll plot that, and it says, falls right here somewhere. And guys, 4, up 1, sits here. That should be enough to say the last piece may look something like this. Would you guys agree? And there's my piecewise function done. Okay. Now, I noticed on the handout, did I ask for the domain and the range on this? Okay, let's do it right now. The domain on the graph, I mean the entire graph. From left to right, anyone describe for me as you go from left to right on the x-axis where the domain is located? How would you describe the domain, the x's? The way it looks. You think it's all real numbers? If it is, it's negative infinity through positive infinity. Now, if you can't see it by the graph, sometimes it's difficult to look at that graph. You could go back here and say, hold on, here what's the x's, the domain. This says start out with bracket 0. You go up to 3. Okay, got that. And this says you include 3. And then union, where else? 0 to 3, we got that. Oh, that was less than or equal to 0. Gotcha. I was going to show you another way here. Negative infinity, up to 0, like that. And then 0 up to 3. Try to do the best I can here, guys. 3, where the 3 is to be bracket. And then x is greater than 3. Michael, I think with what you gave me by that description also, is that really saying negative infinity through positive infinity? Is that true? Same thing? In case you can't see it in the graph there. So guys, there's a domain, range here, guys, would be, looks like, and see if you guys would agree, looks like it's bracket 0, and then goes through infinity. So there's my domain and range. Now though, the important thing is, when you open up the test on Monday, and that's the first type of problem, you guys who just came in here, besides the graph, in the domain and the range, I'll be asking questions like you see on that handout. Who just came in? Johnson? The handout. And guys, I was asking questions like f of a negative 4 based on this function. Well, that's what's going to happen. So you'll be ready for that first question. F of a negative 4, you got to find which of those 3 pieces does negative 4 fit. And right here, by restriction, anything less than or equal to 0, and my negative 4 is less than or equal to 0, I use the first piece, which is negative 4 in this case. So the answer is 4. The next one was f of radical 2. I got to find where does radical 2 in that function fit, and definitely it's not here because this is less than or equal to 0. Radical 2, guys, would fit here. It falls between 0 and 3. So I'm using the second piece to get the answer. So it's going to be 9 subtract radical 2 squared. And I think we're going to end up with a 7. The next one's interesting. Oh, okay. F of ln e to the 4th. Now someone give me some ideas on this one. F of ln e to the 4th. And I see no ln mentioned over there. So what's going on? What is going on? Can anyone give me a simple response for this based on your knowledge of a logarithm, natural logarithm? Believe it or not, that ln e to the 4th is a really simple answer. What is it?
4.
4. This merely says you're trying to find f of 4. If you use the properties of logs, you could move the 4 out front. They have 4 times ln of e, and ln of e, of course, is 1. So 4 times 1 gives you a 4. So now it tells me where to go. 4 fits this. 4 is greater than 3. So I go to my third piece there. 4 subtract 3, x subtract 3. Answer 1. So guys, be careful with these. Next one, I brought in sine. Since your course is over, should be able to do all these. F of sine 5 pi over 3. Now, does anyone remember what the value for sine of 5 pi over 3? And first of all, where is 5 pi over 3 located? Anyone remember? I heard quadrant 4. And if it's down in quadrant 4, sine is negative, the y. And my reference angle is pi over 3, guys. That's one of those on the unit circle. So let me first point out the ordered pair here for pi over 3. Help me out. Is it 1/2 radical 3 over 2 for the coordinates? Except I'm down in quadrant 4. Okay, so I need sine. Sine should be the y coordinate, and down in quadrant 4, the y is what? Negative? And my y in this case is what? Radical 3 over 2? So this comes out to be asking you to find f of negative radical 3 over 2. And we did all that thinking correctly. Now that tells you where to go on that piecewise function. It's negative, so right here it is. I gotta go to the first piece, where x is less than 0. So if I use the first piece, which is negative, this is going to give me positive radical 3 over 2 for a final response. Done. But guys, watch out for little mistakes you can make here, or I can make some mistakes. The next one, last one here says find inverse sine of that handout of f of, looks like, negative 1/2.